So let's wrap up the discussion of dynamic programming by looking at a couple of examples that are a little bit more subtle. Here is a problem that people in graph theory and computer science call maximum independent set. I have a graph or a network, and each node in it has a value. Now, we're going to play a game. You get to take any subset of these nodes you want, and your winnings are their total value. But there's a restriction. You may not take two nodes that are neighbors of each other, that are connected directly by a link. How does this come up, you might ask? Well, in fact, in physics, we often are thinking about systems of hard particles that are not allowed to be too close to each other because then they would overlap, or because there would be too much of a repulsive force between them. And so we would have a similar optimization problem, where in that case, rather than maximizing the value, we would be trying to minimize the energy because we're trying to pack as many of these particles as possible into one space. But this is a nice abstraction of that kind of problem. So, your next quiz is to solve this particular example. What's the total value you can get? Again, you can take any subset of the nodes as long as no two nodes that you take are connected directly by an edge.